Alrighty. So this next question is question 4. It says the graph below shows a composition of f of g where f of x is equal to that and g of x is equal to that. It says write down the rule for fog. This one here is just a straight out substitution. And we get, so fog, so I'm going to substitute g of x into that. And we get fog is equal to e to the power of 2x square root of 1 minus 2x. Next one. It says find the values of x for which it is strictly increasing. Strictly increasing. Okay. So let's look at our graph. So we draw a new graph page. Let's start a new graph page. Okay, so e to the power of 2x square root of 1 minus 2x. What did I do wrong here? I used e instead of the actual Euler's number. 2x. Okay, so don't make the mistake. Okay, so where is it strictly increasing? Well, it looks like from this graph, we've got all these values here where it's, I guess you could say it's increasing, but then the gradient is equal to 0 at this particular point here. So let's find out what that point is. Graph, maximum. Okay, so it looks like it goes all the way up to a quarter, and then from a quarter it becomes a negative graph. So you can use calculus for this, but I've just used the graphing feature. So it looks like it's strictly increasing for negative infinity to 1 on quarters. But the question is, do we include the quarter or do we round brackets it? Now in this case, I would suggest that we use square brackets for this one, because when we're talking about strictly increasing, we're talking about it's all based on the previous value. If the previous value is less than, the previous y value is less than the current y value that you've got, so in other words, at 1 quarter, so in other words, if 1 quarter was up here and the previous value was down here, we're talking about the actual change from the previous coordinate, say xa to xb. If f of xb is greater than f of xa, it means that it is increasing for that particular interval. So in other words, 1 quarter should be included in this case. Now the next question is, it says find the range. So we really just need to substitute what 1 quarter is into this equation. I really should have defined this, but I can highlight and then I'm going to copy. Copies, Control C, hopefully lets you copy, new page, Control V. We can define this as, I'm going to say J of X. Okay, fine. And I'm going to say J of 1 quarter. And J of 1 quarter gives us that value. So, the range is from 0, but we don't want 0. In this case, I'm just wondering, half 2 on 2. Just thinking if 0, so this one here, that's included. Do we have round brackets or do we have let's use a bit of trace, graph trace. Do we get 0? It's a bit difficult to determine if we should include 0 or if it's not including 0. I'm actually going to suggest, contrary to what the solutions might say, is that we don't have 0 as a possible value. I'm just going to check the other side. I'm going to check this other side, see if it reaches 0. Let's see. Graph. What's the minimum value there? trace across. Okay, so we do have a 0 at that point. So let's just investigate if we did have, if we substituted half, of course. So this one here is something you're going to be very careful with. So now I'm going to suggest that we include 0. Reason is because for this instance here, if we've got e to the power of 2x, or if we find 0.5 times 1 minus a half, so 1 minus 2 times a half, which is 1. Square root of 0 is something you can still evaluate, which means that we get 0 for this expression, which means 0 is defined, which means that 0 is part of the range. Okay, important one to consider. Okay, moving on. Find the domain and range of this. So, the domain of fog is equal to the domain of G. Okay, so since the domain of fog is equal to the domain of G, what we're going to do is the domain of G is the domain of G depends on the domain of fog. Fog is going to be this equation, and this equation is defined for the domain all numbers from the negative side up until half, inclusive of half. So since this is negative infinity to a half inclusive, that's going to be the domain of G as well. So that's going to be negative infinity to a half. So if we imagine that this line is going to be drawn for 2x, we only consider that for that section. Now, just checking, it says the range of G as well. So the range of G, okay, so you can imagine this is the full line, which is, what was it, 2x. Okay, so that would be the full line. But since we've got a restriction in the domain, we only want to go to half. Okay, we want to cut this off. So what's the corresponding y value? So this one here is, we've got to substitute half into there. Half, we get negative infinity to 1. Okay, so therefore we would say domain of G is equal to negative infinity to a half. Range of G is equal to negative infinity to 1 after we substitute half into that. All right, next question says, find the x-coordinate of the point of inflection for the graph of fog. All right, so the point of inflection will be a stationary point. Let's have a look. So E, let's write this down. So fog is equal to E of 2x, square root 1 minus 2x. Point of inflection will be when the stationary point equals 0. So let's calculate that. Actually, on that note, it's important to recognize, are we asking to find a stationary point of inflection, or if it's a point of inflection? Keep in mind there's the differences between the two. When we're talking about point of inflection, it's really when the concavity of the graph changes. So imagine it's the same direction, like it's still, imagine a graph going positive, right? But if the graph turns to, I guess, a different shape where you can see there's concave up and eventually there's something that becomes concave down, there will be a point of inflection, but it doesn't necessarily have to be a stationary point, because stationary point implies that there is a stop, or there's like a 0 and there's a change in direction, but not all points of inflection will have that. So there's two ways to do this. The first way I can think about to do this is by on the CAS. Now, if we graph our fog function, okay, you can see here that there's no real obvious place where the graph changes concavity, apart from there's a concave up here and then there's all of a sudden now maybe a change. I'm going to investigate this using analyze graph, and I'm going to use the inflection point, lower bound, and there will be a point of inflection that does come up here. Now, the other thing I need to consider is our domain. We don't want to go anywhere past this, so this is within the domain. That's all good. The other option is to find the double derivative. Now we're going to find the double derivative, and when we find the double derivative, we equate that to 0. And when we equate it to 0, that'll help us find our points of inflection. I'll show you just shortly. So with your CAS, to find the double derivative, as far as I know, what we have to do is we have to nest the derivative. So we've got the derivative that we've worked out first, and then after that, the second derivative will be the derivative of the derivative. And you're just going to make sure that this equals 0 is outside of that brackets, otherwise it will cause some problems. So you can see we've got two answers here. We've got the negative component and we've got the positive component. Now I'm keeping in mind root 2 is about 1.4. 1.4 plus 1 is 2.4. 2.4 divided by that, that's over a half, which means it's outside of our domain, which means we only want to consider this solution as our possibility. So if we go back to our solution here, find the x-coordinate of the point of inflection, I'm going to suggest it's 1 minus root 2 over 4 as our x-coordinate. Now it says, hence find the instantaneous rate of change for the function f of g, correct maximum instantaneous rate of change for the function f of g. Now, when it says hence, it's probably implying that we need to use our answer here, and we can, because really what we're trying to find is fog. Okay, and when you find the derivative of that, we're going to substitute x is equal to 1 minus root 2 on 4 into it. So if we go into our CAS again, okay, and we say fog, let's take the derivative of x of fog. Okay, but we're really finding, evaluating at the point 1 minus root 2 over 4. Ooh, that doesn't sound right. Okay, what have I done here? Oh, okay. I think because we have to evaluate the derivative of fog first and then substitute the value in. So we've got that as our answer. And we're going to say given 1 minus x equals that. We get that as our answer, which simplifies to 1.046. So just to repeat, there is a difference with substituting in and then finding the derivative versus finding the derivative and then substituting in. So you've got to do find the derivative first and then substitute and get 1.04 for this one. So instantaneous rate of change is 1.046, which to 2 decimal places is 1.05. Okay, next question. Okay, the next part's asking us to describe the transformations that turns fog into f. So if fog is this, I'm just going to write them again. 1 minus 2x, and f was just without the 2x. So this is fog. And this is f. We've got e to the power of x square root 1 minus x. We want to turn this first graph into the second graph by using a series of transformations. So at the moment, I can see that there is this x value that is affected. And if we look at the graphs here, this is the graph of fog. And I want to compare how this looks to the graph of f of x. And you can see the blue line. To make the blue line turn into the red line from the y-axis, we need to, I guess, stretch those values a little bit further. So it's either going to be a half or 2. So to make this blue turn into this red, we need to dilate it by, we need to pretty much dilate it by a factor of 2. So dilation factor of 2 from the y-axis as our baseline. Okay. All right, next one here says, question E. Let G be this particular function, and you've got the graphs where they intersect at 0 and A and S. Find the values of K is greater than 1, for which F. Oh, this is a messy question. I have a feeling here we may need to consider the use of sliders because of the fact we've got this K value and there's some sort of intersection. And I'm assuming we need to probably narrow down this value of K until we get an intersection between these graphs that we've put here. So let's try and build this up. Okay, so going back to our CAS, I'm going to redefine our G now as, instead of 2x, I'm going to call this K of x. Okay, so this changes our fog equation, and this will change our overall graph. So going back to this, you'll see it's disappeared. Okay, let's, we've got f of x still there. Okay, so f of g of x has disappeared because now it's recognized a k. Let's draw this. A slider should come up. Now, if not, we may need to make a slider. So let's make a slider. Menu, actions, insert slider. The variable that we used was k. The values that we want to use for k, so k is greater than 1, so we'll start maybe at 1, and we'll use the lowest value as 1, and maybe go, I don't know, up to 5. We'll see where it goes at this point. We'll go step size of 0.5, and we'll see how this turns out. Okay, now our graph's turned up because we've set our slider there. Great. Now, okay, just checking everything's all good. So, this slider is now, the question's asking us to compare it to the graph y equals f of x. So let's do that. So at the moment, k is equal to 1, fog is as such. If I change the values of k, okay, you can see that graph turns as such. Okay, so let's understand what the question's asking us now. The graphs of f of x intersect where x equals 0 and x equals a. If k is greater than 1, find the values for which f of x is greater than the fog graph. All right. So this red line here, what's that point? Trace, I'm going to trace. Okay, it looks like it's at 1, but it's not defined at 1. And that's because it's in the question, it says there is a restriction in that domain. So this point here in blue is changing based on whatever k value we have. Now it's inversely changing. So in other words, if I keep increasing this k value, this intercept here in blue will get smaller and smaller and smaller and smaller. Okay. There's some sort of dilation factor here as well. I'm going to change this to maybe 50 and see how we go with the overall shape. So it approaches 0. Okay, now the other question is that the point of intersection, okay, so the point of intersection is our value for A. So if you imagine a point of intersection right here going straight down, that's our value for A. So that's A here, that's K here, and that's 1 over here. So it's saying that the point A keeps changing as we increase the values of K. So it looks like this area here, sorry, I can't really draw on this, but this area here, that's bounded. So I'm just going to bind this. You can see point here and here. This shaded area is above the x-axis. This is the area that we want. The question is, what's the interval? So it looks like the interval will be wherever A is up until 1 over K, because 1 over K is that inverse relationship in this case. So what I'm going to do is I'm going to propose that we draw up a graph. Okay, if we draw up a graph, this is our normal, that's our normal f of x graph. That's a terrible f of x graph. Okay, and the other one that we got was, okay, so this point here was the, so point of intersection here, we could call that A. We call that 1. And this point here, this is the point that we bounded on top. And this area, this coordinate here is, sorry, I'm just reading the question. So we don't want this shaded area. Ooh, we want this area here. Okay, so this area here is 1 on, this coordinate here is 1 on K. How do I know it's 1 on K? Because if my gradient was 2x, my intercept there would be half. If my gradient was 3x, my intercept there would be 1/3. So if my gradient was kx, it's 1 on K. So our interval for this one is from, and sorry, I did draw this incorrectly. I should probably remake this video, but so it's from, it intersects at 0, intersects at 1 here. And this purple area is what we want to find. Okay, because that's where that thing's above. We don't want that other bit. So it's from negative infinity up until 0. And this section here is from A to well, let's go back to our graph. From A up until 1 on K, because after 1 on K it's not defined. And do we include 1 on K? Yes, because it is an intercept, but do we include A? No. All right, that's a bit of a tricky one, but it does test your use of sliders. I might make a remake of this video as time goes on. All right, so that's the end of question 4.